Hello students, welcome back. As you all know, in my previous session I discussed about matrices, its definition and the various types. So today I'll be discussing about matrices only, the various algebraic operations and basically addition and subtraction of matrices. Alright, so first of all we'll be discussing about addition of matrices and then we'll switch to subtraction. Okay, so what do we mean by addition of two matrices? Right? The topic is quite simple. I'm sure you'll be able to understand it very easily. Okay, first of all, I'll be referring the mathematical definition of addition of two matrices. If A equal to aij m cross n, m cross n, you must be remembering m cross n stands for the order of the matrix, where m is the number of rows and n is the number of columns, right? So if A equal to aij m cross n and B equal to bij, again m cross n. Note here the order of both the matrices is m cross n, that means are two matrices of same order. Then their sum A plus B is defined as a matrix whose each element is the sum of corresponding elements. Corresponding is the most important word here, right? So that means A plus B is equal to aij plus bij m cross n. This can be written as, see, if I vary the values of I and j simultaneously, then what do I get? A11 plus B11, A21 plus B21. Whatever values of I and j I am putting, I will be getting the corresponding elements in both the matrices. That is, if it is the 2 1th element of A, then it will be the 2 1th element of matrix B. Okay, so now we have an example of addition of matrices. So we have a matrix this, suppose this is the matrix A, then I have the matrix B. Both are of order 3 cross 3. You can see it has 3 rows, both the matrices have 3 rows and 3 columns. So what do I do? How do I add these two matrices? See, first of all, in order to proceed in such a question, what do? You just need to remember that you have to add the corresponding elements in each matrix. See, first of all, what do? We just add this element, first element of A to the first element of B, right? Minus 1 plus minus 4. See, what did I do? I have added the A11th element of A to the A11th element of B. Again, A, this is the first row and second column, that means A12th element of A, and this is the A12th element of B. So what are we basically doing? We are adding this element to this element, then this element to this element. So proceeding on similar lines, what do we get? We get this matrix, which gives us minus 5, 6, 4 and so on. So you must have understood this is simple addition. Okay, now we have another example. What is the addition of these two matrices? Okay, one of the mistakes that most of you might commit here is that you might blindly start adding the elements, which would be totally wrong. Why? What did I tell you? Just now I told you, whenever you are wanting to add two matrices, first of all what you need is the order of both the matrices must be same, right? So we first check the order of this matrix, which is 2 cross 2, 2 rows, 2 columns. Now what about this one? It has 2 rows, 3 columns. So order is 2 cross 3. So is it possible to add these two matrices? The answer is simply no. Why? Because the order of both the matrices is not same, right? Okay. So now we have subtraction of matrices. Subtraction is also quite similar as addition. Let's see the mathematical definition first of all. So the mathematical definition says that the subtraction of two matrices A and B is defined as A minus B, which is equal to Aij minus Bij m cross n, where the matrices A and B are A is Aij m cross n and B is Bij m cross n, right? So again we need the same order and we just subtract the corresponding elements. That is, I have a matrix A, B, C, D, and I have a matrix B equal to say E, F, G, H. Then how do I subtract the matrices? Simply subtract the corresponding elements. A minus E, B minus F, C minus G, and D minus H. So we just need to remember two things here, that the order of both the matrices must be same, and secondly we just need to subtract or add, that is we just need to perform the mathematical operation on corresponding elements. Okay, now I have another example. This is one matrix, 3 cross 3 matrix, say matrix A. Then I have another matrix B, which is of order again 3 cross 3, same order. So this implies subtraction is possible. Okay, so how do we subtract these two matrices? Just subtract the corresponding elements. That is, okay, here you just need to subtract the first element from the first element, again the second element from the second element. See, what do we do? Minus 3 minus 5. This gives us the first entry, that is the entry at the A11th place. You can write it here A11. Then this element minus this element, this element minus this element, similarly this minus this. So you just need to subtract the corresponding elements and we get the matrix this, which is the final answer. Okay, so what are the basic things that you need to remember? The basic things that you need to remember are only just 2 points, that only matrices with the same dimensions can be added and subtracted. If you have a matrix of order 2 cross 3, B matrix of order 3 cross 4, they cannot be added. They can neither be added nor subtracted. You cannot perform any kind of algebraic operation on both, right? Then we have the second one is the resulting matrix has the same dimension as the two matrices being added or subtracted. What does that mean? That simply means if I have a matrix A equal to A, B, C, D, this is a 2 cross 2 matrix, and matrix B equal to E, F, G, H, again a 2 cross 2 matrix, then A minus B or A plus B. This will give another matrix, be it A minus B or A plus B. The resulting matrix 2 will have the same dimension, that is, the dimension of both the matrices will be 2 cross 2. Got it? That means the dimension of the matrices, resulting matrix, does not change. It is the same as the initial matrices on which the algebraic operation is performed. Next I have is properties of matrix addition. Properties of matrix addition are also quite simple. This is quite obvious. Commutative law holds true. Like we have commutative law in numbers, 1 plus 2 is 2 plus 1. This is known as commutative law. Similarly, the same result holds true in case of matrices. That is, if I have a matrix A as 1, 4, 3, 3, 2, 1 and a matrix B as 4, 8, 2, 2, 0, 0, then I can, if I perform A plus B or I perform B plus A, both are equal. That is, if you add A to B or you add B to matrix A, the result will be the same. This is known as commutative law. Next, we have associative law. The associative law states that A plus B plus C is equal to A plus B plus C. What does that mean? This simply means that if you have two matrices, say A and B, you add both. This gives, say, another matrix D, and you add this resulting matrix to C, another matrix C. Obviously remember that all the matrices, be it A, B, C or D, would be of the same order. Okay, so we have, if A plus B gives a matrix D and I add this resulting matrix D to a matrix C, then this would be the same as if I add matrix B plus C and this gives, suppose, a matrix E, and I add this resulting matrix to A. The result in both the cases would be same. This is known as associative law. Fine. Okay, so next we have the additive identity. You must all be knowing. So these operations are almost the same as we have in our number system, right? These, at least commutative, associative and identity, hold good in case of matrices. So what does the associative law say? Additive identity. Associative law we have already discussed. So additive identity is, if I have a matrix A of any order, right, and I add it to a zero matrix, null matrix. You must be remembering we had discussed the null matrix concept in the last session. So if I add a matrix A to the null matrix, that will be equal to the null matrix plus that matrix A. This is quite simple, where 0 is the zero matrix and is called the additive identity of the matrix. Now I have, okay, and that's a continuation of the properties. Again, as we have done additive identity, we have next concept is of additive inverse. So if I have any matrix A and I add matrix A to its additive inverse, additive inverse is the negative of that matrix. And how do you obtain the negative of a matrix? Suppose I have a matrix A equal to 1, 2, 3, 4, then minus A would be just the negative of each and every element of matrix A. So A is 1, 2, 3, 4, then minus A would be minus 1, minus 2, minus 3, minus 4. So A plus minus A is equal to 0 is equal to minus A plus A, where minus A is obtained by changing the sign of every element of A, which is the additive inverse of A. Then I have the cancellation law. Cancellation law says A plus B is equal to A plus C. These are the given condition. This is already given, right? So A plus B is equal to A plus C and B plus A. Note that all these A, B, C are matrices. So A plus B is equal to A plus C and B plus A is equal to C plus A. Then we must have B equal to C. This is the cancellation law. Okay. This is also quite simple, but this is on similar lines as we have in the number system, as we deal with simple numbers, right? Okay, so next is, this is another property. Trace of A plus B is equal to trace A plus minus trace B. Okay, now what is trace? I had explained this to you in my previous session, that trace of A is equal to, suppose I have a matrix A11, A12, this is the most general form of a matrix, A1n. Similarly, this is AM1, AM2, AMN. This is a M cross N matrix, M rows and columns. Then what is its trace? The trace is the sum of the diagonal elements. That is A11 plus A22 plus ANN. Right? So trace is the sum of the diagonal elements. So what is the property that we have of trace here is trace of A plus minus B is equal to trace A plus minus trace B. Whether you add or subtract two matrices A and B and then find the trace of resulting matrix, or you find the trace of first matrix, find the trace of second matrix, and then add or subtract whatever is the given operation, the result in both the cases would be the same. We'll understand it once we move on to the numericals of matrices. So now I have listed some of the important properties over here that we have already discussed just now. See, only matrices of the same order, this is the most important thing that is very important to remember. You need to have the matrices of the same order to be added or subtracted. Addition of matrices is commutative as well as associative. This we have discussed just now, that the addition of matrices both commutative as well as associative. Now, cancellation laws hold good in case of addition. The equation A plus x equal to 0 has a unique solution on the set of M cross N matrices. This will be discussing in detail in my future session. I will be discussing on this once I read the system of equations of matrices. Okay, so rest of the properties you must have understood by now. Okay, now I have an example. Solve for x, y, z given that matrix A is equal to matrix B. So I have a matrix A. Let me write its order, 3 rows, 3 columns. So the order is 3 cross 3. Next, a matrix B, again 3 rows, 3 columns, same order. So I can perform the operation whether it is of addition or subtraction. Now I have been given that A is equal to B. What does that mean? This simply means that the corresponding elements would be equal. That means x plus y would be equal to 7. Now this 1 is equal to 1, you can see it easily. I will be taking the values where there are x, y and z so that I can easily find out the values, right? Now I have x minus z is equal to, this will be equal to this element. So x minus z would be equal to 6. 3y is equal to again 6. Okay, so we can find out other values as well. Now z minus y is equal to minus 3, right? X is equal to 5. So this is simply giving me the value of x directly, in fact. So we get x equal to 5. I can get another equation, x plus y plus z is equal to 6. So see, I have got x equal to 5. This equation, this equation, this equation, this equation and this equation. So once I solve all this, see, this equation is also giving me direct value of y. Y is equal to 2. So using this, you can substitute in any of these equations to get the value of z. Quite simple, right? You can just write the values of x, y, z. Quite simple. Next, Another question, okay, I'll be telling you in this, how would you find the value of a matrix D when you have got the values of matrices A and B if they satisfy the given condition that this. So I take a matrix A, you can take any values 1, 2, 3, 0, 4, 5. Then I have a matrix B 4, 5, 0, 0, 2, 1, and I need to find a matrix D such that it satisfies A plus B minus D is equal to 0. So you simply write the matrix A 0, 4, 5 plus 4, 5, 0, 0 to 1 minus D equal to 0. Whenever you write 0 matrix, you'll write it as of the same order as you have the other matrices, right? So since these two A and B are of orders 2 rows 3 columns, that is order is 2 cross 3, so the matrix D as well as the matrix 0 would be of same orders. So you can simply find out the sum of these two matrices. Okay, let me write down the sum also. We'll add the corresponding elements. So I have 5, then I have 7, then I have 3, 0, 6 and 6. This minus D will be equal to 0. Okay, then I'll be writing here. What does this give me? So matrix D can be written as simply 5, 7, 3, 0, 6, 6. This is the required answer, right? Okay, so that was all from my side in this session. I hope you would have understood it. This was quite simple. So do stay tuned for my future sessions also, as I'll be discussing various other concepts like multiplication of two matrices, their properties. Then we'll be switching towards a system of equations, determinants and related features, right? Okay, so that was it, but do practice good number of questions on the topic so as to be able to master it, as mathematics is all about practice. Thank you.